Thunderstorm types, there's this multi-cluster kind of storm. If you look on a radar and it looks like it's organized for a while and then the red area moves over here and the new one forms over here and it's not quite, it's called a multi-cluster storm. It means that increase in wind with height is not enough to hold it together, and the updrafts and the downdrafts are kind of bumping into each other and it's kind of chaotic. You can get severe weather out of that, but it tends to come in bursts when it organizes. And then when it falls apart, you lose the severe weather, and then in a couple more minutes it moves to the next county. All of a sudden it's organized again. It dumps some hail, then it falls apart. So it goes through this kind of cycle. So it can produce severe weather, but it's not the supercell. The supercell is more organized, longer lasting, best chance for severe weather and tornadoes, and somewhat more predictable too. That's important. And then of course the old line of storms, which probably catches our attention more than anything does when we look at a radar. You have more of a widespread wind threat. Pockets of severe weather and tornadoes can occur again along these bowing segments. Ozarks are known to have these. You have a squall line coming out. You have one part of it that's bowing out, really like a bow and arrow, a little bit more than the rest. Danger zone there. You have to watch out for circulations, intense winds, maybe tornadoes forming in that. So in the news, the Moore, Oklahoma tornado of May 20th, 2013, one of 4 strong tornadoes that have hit Moore since the late 1990s, by the way. EF5 strength, strong as you can get. I chased this storm. Here is the tornado warning. This is my GPS position here. That's the radar site. Moore tornado was just ending right there, and we finally got into position. The reason why I didn't go barreling into this is because it was a metropolitan area, first of all, which I had a guest with me. And generally speaking, killing your storm chase tour people is probably bad for business. So we don't do that. I don't do that anyway. Now, if I had known the city, or if I'd been coming up from the south, let's say, or from the west, we probably could have got a visual on this. But coming into a metropolitan area, no way. And most of you don't realize this, but if you've been down to Oklahoma City, that area from there to around Shawnee is like the Ozarks. Very hilly, very wooded, hard to see, more than a couple of miles ahead of you. So we basically found a hill, sat here and waited for the storm to come to us, which tracked just like this. And fortunately for the folks living here, it stopped producing a tornado and never did produce another one, amazingly. So we were in a good position, but it was one of those things where safety ruled over ambition. So, when tornadoes like that form, nowadays, there's always going to be somebody who runs into this thing. Somebody's going to be killed, I'm sure, one of these days, with their camera. And they're like, I got it, yeah, you're going to get it, all right. So that's not the goal. What I do, I look for structure. I think I'm going to have to move it. Yeah. All right. It's not the cardboard that makes the noise, it's hitting the projector, it's making all the racket. There we go. So again, that's a kind of a sidebar, but this storm was very intense. Metropolitan area. It was similar to Joplin in many ways, and I'll talk about that here in a minute. There's a loop, and this is a high-resolution loop made by a radar that sits at the airport. So it scans very often, much more than typical radar does. Look at the curl on this thing as it develops here. Right here, look at that. It's one of those storms that starts to torque before the thunderstorm even fully develops. The atmosphere is so wanting to spin that it begins doing so before there's even a thunderstorm hardly there. Joplin was like that too. And I think that research, maybe there might be something to be said about not only is it an intense rotation, but I think maybe tornado warnings in the future may key in on that. How quickly, what's the difference in circulation between here and here? If that difference is a certain threshold, it seems to me that violent tornadoes are almost a guarantee. Because when this tornado warning went out, again, there's no difference initially, at least, between a tornado warning that produces a brief funnel and goes back up and one that's going to take out half the city. Initially, that wording doesn't exist. And so we'd love to get to a point where that's possible.
Does that body of water have anything to do with, if you watch it, it stops turning right when it gets to the...
Yeah, and there's a lot of temptation to think that would have something to do with that. I don't believe that it does. Most of these features are too small to be effective, and I can almost make an argument for moisture coming off of this enhancing the storm. So I don't believe so, but that will probably live for a while as something that people observe casually and say, well, I wonder if that lake had something to do with its dissipation. I don't believe that it did. What you are seeing is a debris ball right there. I'll talk about that in a minute, but that's actually, that purple right there is reserved for 2 things on radar: large hail and pieces of cities, tragically. So hail is the only thing large enough to do that, and so are 2x4s and cars, things like that. So, and we were by the way, we were about right here, roughly, watching that thing. So that very last image looked a lot like the one I just showed you on the last page. Wait till it gets here. Right. Yeah, right. That one right there. So it just died away there. So it's a fascinating story, a fascinating storm. Here's the beginning of the Joplin tornado. Notice the finger-like appearance. Notice that when this begins, it starts as a multiple vortex tornado. Oops, very good. I just meant to turn the volume down. Hang on a second. There we go. Okay. One more time here. So it starts as a multiple vortex tornado, and doesn't it? You there? I know they got a little bit of movement there. It doesn't do anything. But again, you know, to a trained weather person, you definitely would know something is up. And certainly here, this actually takes on at least a little bit more of a classic tornado look. Multiple vortices rotating around what's going to be a huge funnel eventually. So these people were the only people I'm aware of that were in the right place to capture this at its very beginning. You'll notice that the whole base of the cloud is very, very low to the ground. And then this thing all of a sudden congeals into a pretty violent tornado within the course of, 30 seconds, maybe? And every once in a while, you'll still see the multiple vortex nature of this, although it's becoming harder to see. That bluish-green flash, that was a power transformer, not lightning. That's another thing to watch out for, especially at night if you suspect there's something coming at you. Again, you can kind of see the multiple vortices going on here. But I just want you to look at this for a second and realize that most tornadoes that mature to this point are, especially if you throw trees and hills or buildings of a city in the way, and you are not particularly weather savvy, in other words, you don't spend all day on YouTube watching this stuff, I challenge you to know that there's a tornado. It's really, really hard. That to me, again, if you throw a visibility block about that high in this, what is that? Looks like it's a bad storm. It doesn't look like it's a tornado. Because we all have images in our minds of what a tornado looks like. And these violent ones are almost clouds at the ground. And they don't fit that image, I think, that people are looking for. So when people kind of look around in Joplin, if they're out there right now in Joplin while this is being taped, looking around, they'd be like, they'll see something like that probably, actually. There were a few trees in there, and it looks like a low cloud. They've seen black clouds approach from the west before. You don't see anything turning. You don't see anything right away, at least. Now, if you watch it for a while, you probably figure out something's going on. But again, it's hard for me to say because I am so wired. I'm just always watching all the time. But when you put yourself in the shoes of people who are just living their lives, or not necessarily weather geeks, even those that are, it would be kind of a challenge, I think.
What time of the day was that? I remember, wasn't it about 3:30, 4 o'clock?
The Joplin tornado was between 5 and 6, basically.
Oh, okay.
Yeah.
Okay.
Yeah, about 5:12 to about 5:48, I think, something like that. So the Joplin tornado, I call it insidious, and here's why. The death toll was extreme. It's at about what, depending on where you read, about 150, 160, somewhere in there. Now, of course, when it goes to a metropolitan area, you're going to get a lot of death, unfortunately, even the people who follow the correct procedure. If you don't have a proper place to hide in the EF5 tornado, you're toast. If you don't have a basement, your chances of survival are very, very low. But here's the thing. That's the Joplin track. And by the way, this is a boomerang track. It started going this way, and then it went this way. The general motions of the storms that day, from a meteorological perspective, was actually this way. But this tornado was so antsy to form that it actually carved its own path before the thunderstorm had enough chance to mature. And finally, right here, it said, let's go this way. It's bizarre. So the tornado was calling the shots. The storm was playing catch up. Finally, the storm got so big in the atmosphere, it said, let's go southeast. And chasers typically go south and southeast of storms. So if you're sitting here thinking this is gonna go north of you, guess what? It's not. Anyway, so that's, it took, here's, you can tell by the grid, it started here, so those base hunters I just showed you were over here somewhere. You went from nothing to city in just a matter of a couple of minutes. That's awfully hard to overcome, by the way. The point I wanted to make, though, is that this was the path of the Woodward, Oklahoma tornado of 1947 that killed 150 some people. It was on the ground from Pampa, Texas, in the Panhandle, all the way up. Woodward's right here. It was on the ground probably about a half hour to 45 minutes before it hit Woodward, okay? In today's modern times, Woodward would have had a chance to completely evacuate if they wanted to. Everybody could have left town. Here it comes. If you choose to get out of the way, you've had time to do it. There's no way this would go undetected. So you have to ask yourself, if technology in Woodward, Oklahoma in 1947 were up to snuff with today's technology, what would the death toll have been? Probably a lot lower. That's what makes Joplin even more insidious. We have all that stuff. And we have cell phones and advanced radars and tower cams and internet and sirens, and they have none of that here in Woodward. So that's what makes the 160 total. Oh my gosh, so it's almost like adjusting for inflation. You know how you take your dollars and adjust it for modern day numbers? I mean, if you were to do some sort of bizarre kind of statistical analysis, that was probably a multiple 200 death tornado in equivalent terms. And it's just, I just look at this and I go, wow, that poor city just never had a chance. Of course, any EF5 over a dense city is going to wreak havoc on the town. There's just no way you're going to avoid that. It's going to kill a lot of people, unfortunately. There's a look at the Doppler radar output. Remember I was telling you, greens forward, red away. In this case, they ran out of colors and made it pink and blue. It was so intense. Right next to each other on the radar scan, intense circulation. This debris ball right here again is showing up. So that's hail. That's the city of Joplin caught up in this circulation. So the tornado is right underneath the P, right there. Amazing, 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 and it spun up so quickly. So contributing factors for Joplin were the fact that it went from 0 to EF5 in about 15 minutes. It was the strongest storm possible. Of course, EF5 is the highest rating we assign. It was right on the edge of the city, no time to see it coming. And again, I question, would you have known it was a tornado based on visuals? Most of these are low, dark, and wide, no elephant trunk to look for. There were some siren issues. They went off for a while, didn't go off. They should have been going off when that tornado was on the ground. It took them a while to turn it back on. They're working on those issues. By the way, sirens probably shouldn't be your line of defense anyway. This tornado didn't have a lot of buzz. A lot of tornado outbreaks, depending on the situation, if you're really watching the weather, you have 4 or 5 days of people talking about, oh, there's going to be tornadoes in Oklahoma on Sunday and it's Wednesday. Oh, it's getting worse. So, you have all this time to think about it, react. Joplin had none of that. There was very little severe weather buzz in terms of violent tornadoes for that day. And then finally they upgraded the outlook. By the way, the Weather Service did a great job of warning on this storm, regardless of what you may have heard. I looked at the data over and over, and if I were sitting in the hot seat, I wouldn't have done a thing differently than they did. The only missing connection is this. If those base hunter chasers, they were out there, but they were independent of the weather office. In other words, if the Weather Service could see what they had seen instantaneously somehow, they would have issued a tornado emergency for Joplin immediately. And it may have caught maybe some people's attention. But as it was, it went out as a tornado warning, which the same as every other tornado warning you've probably been a part of, which probably did nothing to you personally. That's the problem we face. More in Joplin comparison, spin-up rate very fast, equal intensity EF5s, around the edge of metropolitan areas. They were somewhat anomalous storms compared to the other storms of the day. So Moore and Joplin were big sore thumb EF5 supercells when the other storms around them weren't even near the intensity or didn't even produce tornadoes. Both were in moderate risk areas for severe weather. Now there's one more up called a high risk. So that's interesting. And Joplin wasn't even upgraded until that morning to moderate risk. So again, the buzz is what you're talking about there. The more you put out a high risk and then you put out the tornado watch, and these are all steps of awareness, I think. And I don't think people largely thought they had much to worry about in Joplin on that Sunday. I think the weather savvy people will probably say, well, you better watch out. But most people just weren't getting an impending sense of anything that day.